students, we have come to discuss about the chapter which is chapter 1, transport system in plants. This is the lecture 2, subject biology or life science, absorption of water and minerals we are going to discuss. You see the two diagrams are here. One is a single root with root hairs. You see a pea plant actually have this kind of roots. Take some pea, keep it in a container, and you'll see after 1 or 2 days, at first the sprouting will be done, and slowly and gradually if you just sow them, the root will come out. Then you can take them out, wash them nicely, and can watch this and find a single root having root hairs. Now my dear children, root hairs are the key factor for the absorption of the water along with the minerals. On the other hand, here is another diagram where a fully grown root hair showing very thin walls. Why they are having thin walls? Because they are to act as semi-permeable membrane. Alright, the semi-permeable membrane is also called selectively permeable membrane because they select the materials which are required for the plants to get in or sometimes to get out of the cells. Here the root hairs are always unicellular. Maybe the root hairs are very tiny or a very large ones. You know, the root hairs may be up to 12 feet long. So in that case, you might think that it is more than one cell. It's not. It's only one cell, a single cell, and having a single nucleus over here. So here are the parts given. You see the vacuole. What is, you think, the characteristic of the plant cell? Huge vacuole. The cell wall, cell membrane is there inside, cytoplasm is there, and so you have the diagram, fully grown root hair showing very thin walls. Let us see here at first. Absorption of water and minerals actually is done by two kinds of cells. They are the xylem and the phloem. My dear children, you have already come to know in the previous lecture that what is xylem and what is phloem. Xylem is responsible for the upward conduction of the water along with the minerals which are known as the sap. While the phloem is responsible for taking the prepared food from the leaves to all parts of the plant. Here you have these two cells or tissues. They make the vascular tissue. They together is known as vascular tissue. They are formed in bundles, so they are known as vascular bundles. Well, there are two aspects. Number one is absorption and number two the conduction. Now why is this happen? Because you know the soil has higher concentration of water. The concentration of water in the soil is more than that of in the root hair. So what happens, you know, this is a process of osmosis where the molecules move from the higher concentration to the lower concentration. So naturally the soil has higher concentration of the water molecules, so the water molecules move towards through the root hairs into the adjoining cells. So in absorption, it is done by the root hairs from the soil. So I told you the concentration of the water molecule is more in the soil and less in the root hairs. Thus water enters the root hairs by the process of osmosis. So the process is known as osmosis, while the higher concentration, the molecules where the concentration is higher, from there they move toward the lower concentration of the molecules. And here you see the root hairs act as semi-permeable membrane. So root hairs act as semi-permeable membrane because they have thin walls. Water enters the cortex. Cortex means the adjoining cells which is made inside. the cells of the inner tissues and they move by leg. Here you see another diagram. This diagram shows the semi-permeable membrane of the which act as the root hair cells. Now see the diagram. Direction of water, H2O, you know that is the term of water, and that is the arrow mark shows that the movement of water was this. And then higher concentration of water molecules are here, and they are going to the lower concentration. You see here it is written the lower concentration of water molecules. So higher concentration of water molecules moving towards the lower concentration of the water molecules. And you see the water molecule is there and minerals are also there. Now, this is a chart, but in actual matter, it is that we have taken a CS, cross section of root. And if you take the cross section of root, what we get? First thing is that the xylem and phloem are arranged. Xylem definitely is inside and phloem stays outside. Right then, there are two epidermis. One is epidermis and below that another layer which is known as the endodermis. And the adjoining cells which I told you is known as the cortex. Here you see the root hair is given, and the root hair, the water entering through the root hair and water entering through the root hair, and the root hair, you know, the bones are very thin. They are single cell, that means unicellular, and they have single nucleus. Well, children, we have come to know about the root hairs and the absorption of water through them. Now, we have one experiment that will show how the osmosis takes place. Here you see the aim of the experiment 1, to demonstrate the process of osmosis. How osmosis takes place. The materials required, what are the things to be done? So children, you may quite do it at your home also. Instead of all those things, potato is very much available at your home, the big potato. You just cut it into a square shape and then scoop a cavity, square cavity like this inside. And instead of petri dish, a large potato is required, petri dish is required, and 25% sucrose solution. Sucrose is common sugar. You can make 100 gram, can take 100 gram sugar and then make a 100% solution, then add water 4 times and take one part of that will give 25% solution. Okay, that you can take and keep. And then the scooped potato is kept in the petri dish, and the more than half part is immersed, means dipped in the water, and half part there is a pin stuck in it, and the cavity is filled with 25% sucrose solution. Well, you see, we have another. This is known as osmoscope, made by us. That means you will. A beaker is taken, and in a beaker, the sliced potato is given is a cavity. The pin is here, and same 25% sucrose solution is put over here. This is known as potato osmoscope. The osmoscope made by you by taking a huge potato, and it's very familiar to you. At the market, you can get a good sized potato. Later on, you can use it for cooking also, no problems after the experiment. Let us come to see how it happens. The live potato is taken, petri dish, 25% sugar solution, and the method. The potato is peeled. First you peel it off. Peeling means take out the skin of the potato. Then sliced at the bottom, niche सीधा कर दीजिए, and just put it square shape. Then what you will do? To make a cavity inside it, and then in the cavity you put 25% sucrose solution and then leave the apparatus. This is an apparatus, it's made, and after keeping the solution, you leave it for some times. Why? Because you actually give them the time to go the solutions, that means the osmosis to take place. Well, observation, what you are going to observe, children? The liquid in the cavity rises. The liquid, what was the level? It will be rising. Why it is rising? Rises. And infrared, why it is happening? Now the concentration of water is more outside the perimeter. 100% solution of sucrose is less concentrated than that of the water molecules in the media or in the materials. Then what is happening? You know, in osmosis, the molecules move from the higher concentration to the lower concentration. So that is why the water gets in and the level is increased. Same thing is happening here also. The level of the water rises. That shows the osmosis has taken place. Shows that osmosis has taken place. Now, one more experiment. The experiment number 2, where you see we can take the materials required, one plant, small sapling, along with the root. You should put it out of the soil and wash it nicely, so keep the roots intact. And then put it inside a test tube, or you can use a beaker also. Then you put that and put in such a position that it must not be disturbed. You can put a stand over here, so keep it out like this. And then it is filled with water, and at the top put some oil. Why do you put the oil? Because the oil will prevent evaporation. Because evaporation is a natural process. If there is water, if you keep it in a plate, slowly and gradually it will be evaporated. So you keep it like that. So it will be evaporated. But you have to go through the experiment, and that is why you put some oil. Now what is this experiment for? The aim of this experiment is to show the plants absorb water through their roots. And thus we have put oil here to prevent evaporation, to show that it is not by evaporation but by the roots the water has gone into the or taken by the plant. Now what are these? The materials required: a young baby plant, that I told you already, a beaker or a test tube is taken, and water is required. Now what is happening here, you know, method. Some water is taken in a test tube or a beaker, that I told you earlier, and then a young plant is put in it. We put some oil to prevent evaporation, that I also have explained, and then we come to go. Level of the water is observed. At first we see the water level here. What will be the water level over here? That will be observed in the beginning. Suppose the water level is like that, because the oil is kept on top of the water to prevent the evaporation. Now what's happening, you see? Leave the apparatus undisturbed for some times, because to give them the time for the absorption by the roots. Well, after some time when you come back, then you see the level of the water will go down. Why? Where does the water go? It cannot go by evaporation because the oil is there, isn't it so? Then the roots, they are absorbing the water for the plants. And that is why it has gone, the level has gone down. This shows the absorption of water is done by the roots. So in observation, the level of the water in the test tube, here it is the test tube, but you can take it in bigger, that is observed, and then the plant has absorbed the water through the roots. So this is an experiment to show how the roots absorb the water. Thank you. Well children, after the absorption of water, we come to know about the absorption of minerals. You know, the minerals are required for the plants as well. As you need the minerals, the plants also need the minerals. Here you see the absorption of minerals. The minerals required for plants are usually Ca, the formula of calcium, then K is potassium, Mg is magnesium, and nitrogen. When you know the nitrogen is the bodybuilding material, so in plants also nitrogen is very much required. Well, involves in two processes. These minerals are absorbed in the plants by the root hairs, but they involve two processes. One is diffusion, the another one is active transfer. Now you see here the two diagram has been given. One is this shows the root hairs, soil particles and minerals are there. This is the process of diffusion, soil to root hairs. That is from the soil to the root hairs. Here the region of higher concentration to region of lower concentration, that is diffusion. Okay? Concentration. And movement of salt molecules takes place when the concentration is higher in the soil. Here the concentration is higher in the soil than in the root hairs. So this is one part. The other part, the movement of mineral ions. Movement of mineral ions. Okay. The movement of mineral ions, the mineral ions from the soil to the root hairs. That is from the region of lower concentration. That means in the soil the concentration is lower. Region of the lower concentration to the higher concentration. That means it is known as the active transfer. It is known as the active transfer. Minerals into root hairs. Here the concentration of minerals is lower or low in the soil than inside the plant, inside the root hairs. This is how it takes place. This is how it takes place. Well, children, now we have to see the transport of the water and minerals, which is known as conduction. Which is known as conduction. Now, root hairs absorb minerals, which is known as by active transfer. By active transfer. That you have already come through the diffusion and active transfer. Here we have the root hairs absorb minerals by active transfer. They absorb by vascular system. And this vascular system, the transport system, water and minerals by xylem and phloem. The water and the food by the phloem and the sap, that is the minerals and salts by the xylem. Here you see, this is a theory which is known as ascent of sap. And this theory has been given by a great scientist of India, whose name you might have already known. He is the Sir Jagadish Chandra Basu, or Acharya Jagadish Chandra Basu. He had given the theory of ascent of sap. And when you grow up, you will know that Sir Jagadish Chandra Basu has also proved that the plants can also show the sensitivity towards the stimulus. So what I am telling is the transport of the water and minerals, which is known as conduction, and the root hairs absorb minerals by active transport to the cortex, from the root hairs to the cortex, and they absorb by vascular system the transport of water and also the prepared food to be transported to all parts of the body, that is by phloem. And this going up of the minerals and the water is known as ascent of sap, and as I told you, it has been given by J.C. Bsnes. Now you see, minerals and salts accumulated by xylem, reducing the concentration of water, and a concentration gradient is created. Due to continuous flow of water, a pressure is created which is known as root pressure. What pressure? Root pressure. So this root pressure, and due to continuous and constant evaporation, because the evaporation is going on by the transpiration, a suction force is developed. Suction force means the force which can pull, that is suction force, is developed. This is known as transpirational pull or transpiration pull. There is a tendency of water molecules to stay along, that is stay together, and by that they create a cohesive force. The children, you have come to know about the molecules by chemistry, and there you find the molecules stay along with the other molecules. And the force among the two molecules is known as cohesive force. That is also happening here, the cohesive force in the water molecules. And it maintains a continuous water column in xylem vessels. In xylem vessels, a continuous water column is made. And if the water column was not made, the ascent of sap theory would not have been worked out. So that is why this is the key and the secret that the continuous flow of water goes on. Here we have the diagram for that. You see a plant, and in the root take more water by osmosis, that you have already come to know. That root hairs take by osmosis, then they send into the cortex, and sap is pushed forward by the root pressure. As you have come to know about the root pressure, that pushes the sap. Sap means the water along with the minerals, and then the water is pulled up by the xylem. So children, the cohesive force continues the water level by the xylem from the root towards the leaves. And here is the diagram that follows. You see the root take more water by osmosis. Here's the diagram. You see the root hairs take the water by osmosis the most. Then it comes as the transpiration pool or the pressure of the root pushes the sap upward, and thus the water is pulled by xylem. Then you come to what is replaced by inner cells. Now when one cell is empty, that means the water has gone, then it has to be filled, and that is filled by through the inner cells. They supply the water to that particular cell. And finally, the stomach. You know, the other day I have explained, in the lower epidermis, there are the stomach, and there are many, that's why in plural they are known as stomata, and those, they are responsible for taking in carbon dioxide, leaving oxygen into the air, they are taking in, and they are leaving the water by transpiration. And whenever the shortage of water comes, the stomach closes itself. And sometimes, by the shortage of the water, the leaves and all droop, and can even, the loss of water can cause the death of the plant as well. Now we come to the part where we see the transport of food materials by phloem is there. Phloem is another conducting tissue which actually supplies or transports the food material to all parts of the body. The produced food is nothing but sugar, and then molecules, these sugar molecules, these are transported by phloem. The sieve tubes, there are in phloem element you see the sieve tubes, they are arranged one by one, makes a long tube by which the food can pass. To your knowledge, there is a plate also which is known as sieve plate. So that when you will come to the function and the higher studies of that, you will understand what is the function of that. Right now, the sieve tubes in phloem are placed one by one above the other, and it makes a long tube. The movement can be upward as well as downward or to all parts, because the prepared food is required by the plants to all parts of the plants. Otherwise, the development or growth will not happen. Well, children, we will conclude the lecture 2 by showing you two experiments of the conduction of water and transportation of the food materials. Number one, you see the aim of this experiment is to study the transportation of water through xylem tissues. Xylem tissues, you know, they are responsible for the upper conduction of the water, along with the minerals obviously. So, the materials required for this experiment is a soft flowery twig with roots, preferably white petroleum, because white color can be colored easily, that is one. Pink ink is also required, a beaker, water and microscope, because without microscope you cannot see the cells. They are very tiny and they can be magnified with the microscope, so you can see properly. Well, the method, water with pink color is taken in a beaker. It's taken, we put the plant in it and keep undisturbed for an hour. Well, a thin slice of the stem is taken on the glass slide. You know, in the microscope there are glass slides are provided with cover slips and they cover it and to see what. So glass slides and is there and the slice is taken, very thin slice. Well, a few drops of water is put on it to just clear, because more accumulation of the color will be there, so we will just only see the black. So if you wash it with little water, it will come distinct, and so you can see, observe very nice. Well, observation, the xylem tissue is stained pink. That means the pink color has been absorbed by the xylem tissue. Why? Because the xylem tissue conducts the water. So they have conducted the water with the color, because we have put pink color water there. Isn't it so? That is why they colored pink. Well, what is the inference? Inference is, it proves that xylem tissue helps in the conduction of water. And this is the diagram for that. This is the xylem transports water in plants through this. This stem is sliced and taken a slice like this. While you see, this is, I have drawn in black, but this pink color patches. These pink color patches are there for the xylem. And the phloem tissue is this, the dark one. The phloem tissue is the dark tissue. Here you see the phloem tissue is dark one. Now, so this is the experiment, and that proves the xylem conducts the water. Coming to the second one, that experiment, the aim is to show food transported by phloem. Materials required: a plant pot, water, a healthy plant with thick stem. Well, method is, we cut the thick stem of the plant deep enough to penetrate the phloem, because phloem is outside, and then cambium, then xylem. So we have to cut this up to the cambium, but not the xylem, because if you cut the xylem, the plant will not have anything, it will die. So carefully cut up to the xylem and water the plant regularly and leave it for some days. And what we will observe after that, the part of the stem above the ring, this is the ring, above the stem, above the ring, the stem is swollen. Swollen means grown thick. Why? Because the food prepared here has been transported by the phloem, but could not go because there is no phloem tissue, it doesn't cut out. So phloem will be accumulating all the food over here. And the below part, it will stop growth because the phloem tissue is not there and the food is not transported to that part. And that is why the inference is, this is because the manufactured food is transported up to the ring, not below the ring, because it does not reach the lower part. So this proves the phloem conducts the food materials. Thank you and have a good day. I wish you will study well and be ready for the next video to come. Thank you.